Good morning, and thank you very much for joining my lecture. My name is Marco Döttlinger, and I'm an Austrian composer of experimental music, sound, and installation artist. I'm also lecturing at the INM, that's the Institute for New Music at Mozarteum University in Salzburg, Austria. Thank you very much to Professor Theo Herbst for inviting me to this event. My lecture has the title Composing the In-Between. I will try to show how I applied something called neural synthesis in a recent work of mine. This piece is called Common Grounds. The subtitle is An Anthology of Impossible Artists. And it will also be premiered at the festival. It consists of 10 short audio tracks at the moment, but I consider it a work in progress, so some new tracks will join later, perhaps. Before we listen to some examples, I want to sketch very briefly and without going too much into technical or mathematical details what this type of algorithm is doing and how it is applied. Neural synthesis is a part of the huge field of machine learning algorithms. An artificial system learns from examples and can generalize these after the learning phase is complete. To do this, machine learning algorithms build a statistical model based on training data, which is tested against the test data. Neural synthesis is basically the term describing sound generation based on artificial neural networks. A special network type, which was developed to process sequential data, such as time series, which is anything in a sequential fashion, such as text, language, and audio data, means speech or music, is called RNN. This stands for recurrent neural networks. RNNs use sequential data or time series data. These deep learning algorithms are commonly used for temporal problems, such as language translation, natural language processing, speech recognition, or in my case, or in our case today, sound synthesis. They have a form of memory as they take information from prior inputs to influence the current input and output, so the output of RNNs depend on the prior elements within the sequence. They utilize training data to learn. This means that a corpus of data is provided to the network to learn its features and trying to generalize it in order to be able to predict the next sample. An RNN type to synthesize raw audio waveforms was introduced in 2017, and it's called sample RNN, sample recurrent neural networks. So sample RNN models are trained on a corpus of audio files and synthesize new audio files. In 2018, they came to wider prominence through a group of musicians and researchers called DadaBots. They released a YouTube stream of so-called technical death metal music and called this Relentless Doppelganger. They have also released the code and the sample RNN implementation I used for my work is by Dr. Christopher Mellon He's a software engineer working at RNCM. That's the Royal Northern College of Music in Manchester, England. If you want to give it a try, I share links to GitHub pages and papers or web pages of used resources at the end of this lecture. Let's listen to two examples. The first one is an excerpt of the famous DataBots stream of technical death metal. A sample RNN model is trained on music of a band called Archspire. And the second example is by Dr. Mellon of RNCM Manchester, and he has trained his implementation of sample RNNs on Beethoven's 32 piano sonatas. So he was using about 10 hours of Beethoven's piano sonata music. So, what we can hear, I think, is quite impressive if you consider the task. The model listens to some audio, generalizes it, or tries to generalize it, and outputs infinite versions as audio tracks. It's also important to mention here, I think, that we are not talking about a symbolic form of musical notation or representation, such as MIDI. These models are able to take audio files and output audio files. What we also hear is a lot of noise or digital artifacts, less in DataBots stream because of the, let's say, overall noisy aesthetics of metal music, probably. And this noise also comes because of the lower sample rates of 16 or 22.05 kilohertz. It takes lots of time and computing power to train models and generate sound in high quality audio rate. But even it's kind of noisy and has this lo-fi aesthetics, for me the most interesting point here as an artist is that the way this algorithm tries to formalize or generalize the given musics is very much different, I think, from what or how we would formalize or hear as human beings. I think the Beethoven example points this out. It sounds like a piano, of course, and it has somehow the classical aura or intention. If you want, maybe intention is a too big term here. Nevertheless, the result cannot really be compared to a piece by Beethoven. That's quite obvious, I would say. This aspect was decisive for me and made me think about other ways to use this technique. If we try to break it down, this model can be seen as a general representation of Beethoven's, in this example, sonatas. This means that from one sample to the next sample, it chooses the best fitting one and in this way slowly constructs a sound, sample after sample, but in a statistical fashion. These predictions possibly generate sequences of sounds that a composer would not choose, I would claim here. So, after this little background, I would like to talk a bit about my work, Common Grounds, an anthology of impossible artists. This work exaggerates this aspect even further. I trained a sample RNN model for each of the short pieces in this anthology, but not with a homogeneous or consistent data set. Consistent in the sense of one dedicated style or a band, a group of musicians or a genre or a composer, etc. Rather, I have created a training corpus that contains for each piece two completely incompatible aesthetic positions. These incompatible positions I have distributed at a ratio of 50 to 50%. So it means half and half split it. Incompatible can mean different things here. For example, that the two musical or sound expressions are aesthetically or ideologically or historically or stylistically inconsistent, contradictory, and impossible. So the model for each short piece is a model of an impossible artist's music, if you want. I have tried to find some names for artists intuitively derived from the names, titles, or lyrics of the inputs. Take, for example, and we see or hear it also later, take, for example, the group Airport Music Scholars. These words want to reference here a vocal quintet dedicated to the polyphonic and chromatic music of a Renaissance composer from Italy. It's sacred music written for human voices, combined with a producer of so-called ambient music. Ambient music meant to be functional music made in a studio with electronic equipment by one person. I think we can see the fundamental differences here. Not every so-called impossible artist track can be deciphered clearly. That's not so important to me either. When listening, it becomes obvious, so I hope, that certain artistic positions are colliding here. Also, when choosing the training data and half-half mixes for each piece, I have no reservations at all about aesthetic positions that I would not represent as a composer. Here you can see the track list of the album at the Impossible Artists Bandcamp page I created. I will go through the tracks one by one and tell you what the model was trained on. So the first track is death metal grindcore music of one band and song cycles from the 19th century for voice and piano. The second track is polyphonic Italian Renaissance music and electronic ambient music. The third track used the training set of traditional Austrian folk tunes and the debate of two philosophers. Number 4 is traditional Austrian music for traditional dances and a pioneer free jazz quartet. Number 5 features modern jazz trio and classical piano trio compositions. Number 6 is an Austrian Schlager or pop music act and a thrash metal band. The 7th track used ASMR content of a YouTube channel and the famous new music or avant-garde opera or let's better say music theater. Number 8 is string quartets of a composer of so-called new complexity music combined with music of producers of IDM, electronic music. IDM stands for intelligent dance music. Number 9, it's a free jazz piano improviser, solo improvisations, and classical sonatas written for piano. And finally, track number 10 is using dodecaphonic violin concertos of the Second Viennese School, concertos for violin and orchestra, and music of a hip-hop group of New York, from New York. Let's listen to some of the outputs the model suggests. Also to give you an impression of the quality the outputs have. If you remember, the model is trying to predict the best next sample, but this can also fail. And actually it is failing quite often, and the generated results are or can be noise, bursts, or silence. So we listen to some outputs of the last model. It was trained, as I said, on famous violin concertos of dodecaphonic composers of the so-called Second Viennese School and a hip-hop rap group from New York. As you can imagine, the process of creating this work is very much different from working on other musical projects. A lot of listening to generated outputs is involved, and also the level of control compared to developing music in computer music environments like Max MSP, Pure Data or Super Collider, etc., or working with hardware or modular synthesis, the level of influence or control for the composer is really limited. I call this work of mine works of conceptual art, or music if you want, following the artist Sol Levitt, who has coined the term conceptual art. He says in the famous text, Paragraphs on Conceptual Art, and I quote, "The idea becomes a machine that makes the art." In my case, the idea of a compilation or anthology of impossible artists was taken literally. Each sample RNN model I trained is actually, it is the machine that makes the music. Nevertheless, the outputs are curated to short representation pieces. As we have seen in the examples the model is giving us, not everything can be used. So the last step of putting the pieces together is curating the outputs I liked a lot. And this also means, of course, that they could be assembled quite different. But as far as I can see, this does not contradict the concept of the work. In closing, I would like to raise a few very general questions about this technology, without giving or having solutions, of course. Firstly, you may have noticed the maybe for some of you provocative word composing in the title of the lecture. Can I call myself the composer or author of these works? But probably this question is obsolete, I don't know, just like in the case of Marcel Duchamp's work, Fontaine. We all know he puts the ready-made or found object of a pissoir into an art context to address something else. Secondly, there is legal implications, of course. Without a corpus of sounds or works of artists or musicians, composers or bands, the training of such a network will be impossible. That's also another reason for the, as you wish, funny or absurd or ironic artist titles of this anthology. I have not directly mentioned the used materials because there is, of course, copyright issues. Of course. However, because I'm not selling a commercial product here, but would describe these pieces in the frame of artistic research, I have neglected this. But let's take the other perspective and sharpen this point a bit. For, let's say, a film composer, it will be quite hard to prove that his or her works have been used by a tech company selling AI-driven film scoring applications. So at the end of the day, the, also the project references also, if you want data sovereignty, to formulate this on a more general or even political level. Thank you very much for your attention, and I'm very much looking forward to some questions you may have. Thank you very much.
Marco, good morning. Can you hear me?
Yes, hello.
I thank you so much for most interesting presentation. I'm just waiting for the cameras to jump back. Thank you to our technical team for helping us. I'm bristling with questions. You can see the chat. You can see the chat, and I think I've got your attention for a couple of minutes, all for my own, huh? Because
Of course.
it's fantastic. First question regarding training data. This way of working, of composing, I would call this composition, musical composition. This
Mhm.
way of working relies on training and on training data very strongly. Is that correct?
Yes, absolutely. So
Okay.
the workflow is normally in machine learning. You have a corpus of um, training data. In my case, it was audio files.
Yeah.
They are in a lower sampling rate to
Ah,
reduce the file sizes, the amount of samples, and
right.
then it's I don't know, from 8 to 10 hours audio content.
Yeah.
They are sliced into chunks of depends on the model I did, 8 to 10 seconds.
Uh-huh.
Um, then you have the ratio of 8 to 2. So eight like parts is to train the model, and 2 parts is to feed after training validation
Ah,
um, um, files to check the accuracy of this model, and then it generates sounds dependent on what you give it to learn.
I see. I see. Fascinating. Fascinating. A question following on that is I'm always fascinated to think about what sort of musical content is encapsulated in the training data and is then used to train an outcome. So if sorry for interrupting. So if one uses audio uh, sections or wave files as training data, I'm always fascinated to think about, you know, that is the outcome to another composition process, but how much actual like musical creative elements are contained within the audio and therefore can serve as training information.
Mhm. That's a very good point. Also, because I also raised these questions: is it a composition or not?
Mm,
Because in my case, I also stated to call it conceptual somehow, because I
okay.
was using outputs of 2 other artists and mixed them to formulate this idea of impossible artists. Like if you think about having one artist's head and it's filled with two
Yeah,
completely
right.
inconsistent thoughts, which is not possible for a human being. So this was interesting for me. So I was using like works of artists, finished works, and they have not been done. Of course, for me to train a model, of course, no,
Yeah,
I fetched them and used it, but it's of course also another way of using this technology or algorithm
mm,
could be to write some, I don't know, max batches or super collider code to generate training data, or work with an instrumentalist or an improvisation group
yeah,
doing some sessions and generate or um, create a training corpus which can be later used with the same group, maybe
yeah, yeah.
as a file to yeah, fixed media
Sure,
part of
sure.
a piece. Yeah.
Right, right. Um, to shift gears somewhat, have you at all investigated Google Magenta?
No.
Uh-huh.
No. This the this sample RNN implementation I was using uses Google's TensorFlow 3
Yeah,
library, which is I think also Magenta. I'm not sure, but it's yeah, it's of course it's also Google
Yeah,
technology,
sure,
which was used here. Yes.
sure. I find that we are living through like an explosion of potential for this type of work. It is to
Mm-hmm.
have everything browser based with um, and free, free access to code. And yeah, it is just a very, very these are very exciting times to work in. Um, have you at all worked on using training data to train information regarding a specific parameter in a composition? So maybe one training set, one process to work just on timbre, another on
Mm-hmm.
meter and rhythm, etc.
Mm-hmm. No, not yet. But this is also on my list. This was the first machine learning project I did on my own. I did something before with a friend of mine who was doing the coding and the implementation stuff. So
Sure,
this was also for me a big, let's say, learning process.
sure.
And there is of course, a lot of possibilities to approach this system. Also to split, as you mentioned, to split some tasks of a composition in terms of training something to do this, like timbre, or to, I don't know, what's the next pitch, or etc. There is so many really
Yeah,
possibilities to apply it, and this was the first for me the first time using this kind of
yeah,
systems, and I came up with this idea of mixing the two things and trying to how can I say, um, to compress these
yeah,
differences, and
yeah.
simply hoping something comes out which
Mm,
um, is interesting. So this is also, of course, it's kind of black box technology, because if I trained a lot of models with, I thought, oh, wow, this could be interesting
mm,
content to use, but at the end it was totally failing. It was only
sure,
noise, and you have not heard anything
sure,
from the
sure.
input. So
Yeah,
this
yeah.
can also happen.
Yeah, that is a good outcome. I think one learns a lot from so-called failure. But the thing that really excites me is that we're talking about possible musics, so potential outcomes that, and living in the third world, in the developing world, and the university environment within which I operate, I find that is something that is so lacking, is the bravery to not only dedicate ourselves to constructing the past, and reconstructing the past again and again, but to look towards the future, and this interaction between, shall we say, AI and musical composition, um, limitless potential, limitless possibility. So it's not exactly a question, but I'm rather making a statement. And
Mhm. But let me comment on this a bit. It's very interesting, also for me. Or this is also the reason um, I dive into this and want to do this. Is there is lots of potential to get surprised. This is a point which fascinates me, also in generally in algorithmic composition. Um, it's quite easy to how can I say, to describe a process.
yeah,
Let's say it can also be like a deterministic or a stochastic algorithm, etc. It's,
yeah,
you easily describe what the thing is doing, but then you get some outputs which
mm,
you would not have been
yeah,
able to imagine
yeah, yeah,
yourself, and then you need to
mm,
how should I say this? You need to react on it, and
yeah,
this is also, it changes also your way of working and thinking about music. So
yeah,
what you were asking is um, progression or finding some new things. I think this or advanced audio technology or working
mm,
with algorithms, even like um,
let's say, easier ones in a super collider batch, etc., um, gives you a lot of insights also on your own work and biases, I would say.
Yeah, yeah. That is so extremely powerful. It's such a good point to arrive at in a creative process. I think of it as encountering perhaps intelligence that's slightly smarter than myself, which isn't very difficult, but it happens easily. But this is a crucial point. I am amazed by outcomes in these processes. I'm stimulated by them. I don't think that they're taking away the job of a composer or whatever. Um, um, yeah,
No, I
it's
would also say not at all. I mean, people are now like, oh my God, singularity, etc. Maybe they're
yeah, yeah, yeah,
I'm just started with machine learning. Maybe I oversee a lot of developments, for
mm,
sure.
mm,
But if you break it down, it's a statistical model, as a very very complex thing, which gives you feed it with something, and then it gives you an output, and then
sure,
you have to react on it. Like you have to also, if you, I don't know, if you do a serial list or dodecaphonic style or any kind of
mm, mm,
musical piece, you also have a set of rules, and then you have to react. So the, I would say,
sure,
the, even in jazz, the style of your, I don't know, playing is, you know, some rules, and then you apply them your own way.
yeah, yeah, yeah. Yeah, I think thinking is a universal process. It's not necessarily limited to we cannot anthropomorphize it. I think thinking and logic exists, in my opinion, outside of the movie that plays off or plays out in our head. Um, I'd like to speak very briefly about the work that you're presenting in the concert.
Mm-hmm.
Mm, you've written excellent program notes, but could you perhaps elaborate slightly on that composition, please?
Yeah, of course. That's the, so the lecture I did, we heard now is, where does this come from? Data boards, some historic, briefly, um, um, sentences. The this conceptual album which will be presented, that's the, it's called Impossible Artists, and I call it, the album is called Common Grounds, and it tries to, for each track, I'm using two totally indifferent or inconsistent data sets to to yeah, to force the system to mix two ways of thinking, to give me something which is not, would have not
Right.
easily be possible in a human composer's head. So this is the idea, and I combined a lot of arbitrary, it seems, musics, like, I don't know, Renaissance music of, I mean, I can say it now. One piece is Gesualdo,
Mm-hmm.
motets, combined, half Gesualdo and the other half ambient music of Brian Eno.
Okay.
Everyone knows, of course, and you can see here the difference, in terms of when was it composed, how was it composed. And Eno is working in a, or an ambient producer is working in a technological context in his studio, while the Renaissance composer was writing this down, needed singers, so it's for vocal quintet. It has ambient music was meant to be functional music, also the sacred music, to a certain extent, but it's, from where it comes and how it sounds, quite different. And then this have been the ideas of every track, I would say, to find some interesting contradictions somehow.
Sure.
And then what the model is doing, it tries to find a common grounds. So that's the thing which is fascinating for me. What is in-between. What do these two things have in common? And that's what the model gave me. There is so much crap to filter out, but then I was generating sounds, and I was only curating it and doing a montage, and that's this short tracks.
Yeah. Incredible, conceptually so beautifully thought through. I have to congratulate you. It's magnificent, magnificent work. Marco, we've taken up a lot of your time. I hope we can continue this discussion, and obviously invite you down to Africa in the near future. Thank you so much. And
thank you very much for your intention and inviting me to this event. Thank you.
Bye.
Bye.